Good afternoon. Today, our guest is Sergey Alexandrovich Pulinets.
There was a famous experiment in the area near the town of Parkfield in California. This is the famous San Andreas Fault, where earthquakes occurred with remarkable regularity. That is, every 22 years plus or minus 6 months, there was an earthquake with a magnitude of about 6. These observations were carried out practically since 1907. Regularity was observed, and it gave hope that it will be possible someday to predict earthquakes. The next earthquake that was predicted using this time frame showed that it would be somewhere around 1993 with a magnitude near 6. They were waiting and waiting for this earthquake, and it happened in 2004. This periodicity was broken and led to pessimism in the ranks of seismologists. A number of other factors led them to the conclusion that a short-term forecast of earthquakes is impossible. There are not only destructive processes going on inside our planet. It would seem that if there was a huge earthquake and everything was destroyed internally, then what would be left of our planet's tectonic plates? Is there some form of a regenerative function? As it turns out, there is a process of tectonic crack healing and regeneration. My colleague, Professor Glitko, who works at the Academy of Sciences as well, is one of the leaders in Russia in the field of geophysics. He specializes in studying these processes of tectonic crack healing and regeneration. He has found that they are filled in and the structure of the Earth's crust is restored through multiple processes, which shows that our planet has many properties of a living organism when it comes to healing damaged parts of the whole. And there are many different and sometimes hard to explain processes that occur. To talk about the problem of earthquake prediction, in the beginning, the approach was purely mechanical. If you apply stress to some substance, and you know the stress modulus, elastic deformations take place next. Then cracking begins, and then it ruptures. It was thought that you could calculate the probability of the whole thing like this. First of all, the Earth is very heterogeneous. There are many forms of dense rock, and on the other hand, there is sand and soft soil. They have completely different roles under stress. These can be pressed or shifted in unstable different gradients. To add to this, there is water, which is incompressible. As the Parkfield experiment demonstrated, such a mechanistic approach is no good. Then, for a long time in the 1970s, seismologists from the United States, in California, and Soviet seismologists in Tajikistan, Uzbekistan, and the Caucasus worked in friendly cooperation very well. There were polygons where various anomalies that occur on the surface of the Earth were measured, the so-called physical precursors of earthquakes.
Is this the release of certain gases?
Release of gases, groundwater level, change in the gravitational field, change in the magnetic field, change in the conductivity of the Earth's crust.
Does it also change?
Yes, it does. Well, because if you compress, respectively, the conductivity changes. The same as filling up with water changes conductivity, right? The change in the velocity of seismic waves. Waves of different types spread in the Earth's crust, transverse and longitudinal. And so, the ratio of transverse to longitudinal wave velocity also changes before a strong earthquake.
Within days, I guess.
No, it is weeks and months. Such things as radon emissions, changes in groundwater levels, they take quite a long period of time, about a few weeks, even months. But then a general analysis was performed, and seismologists from all over the world were involved, and they analyzed all these physical precursors from the point of view of strict statistics, and they came to the conclusion that the reliability of this forecast is equal to 0. And again, a short-term forecast is impossible. There was such a date in 1997 when in the journal Science or Nature, I believe Science, there was such a discussion of seismologists, and they, as if at the CPSU, Central Committee Plenum, decided that earthquake prediction was impossible. The word forecast disappeared from scientific literature in general. The articles were not published. And it had a very negative impact on the development of seismology and geophysics in general, because young scientists stopped doing it. They wanted to progress in their field, and if your articles are not published, you are ridiculed at conferences. No one will do it. But this period of seismic extremism has passed. Somewhere in 2005, in the United States and Russia, the councils on forecasting earthquakes were already restored and began to study this issue again. But, in my opinion, this period has had a very negative impact in the sense that mathematicians began to play a major role in seismology. It was statistical methods that formed the basis. What are they? They examine the flow of seismic events in this area, its distribution over time, space, magnitude, and so on. And then on this basis, some conclusions about what will be in the future are made.
It is just a probabilistic approach.
Yes, it's a probabilistic approach. It is also confirmed, well, it has a physical basis in the fact that an earthquake is a stochastic process, and any random heterogeneity can develop into an earthquake. But these heterogeneity incidents emerge chaotically, and we cannot say which one will then turn into a seismic event. We cannot say that these methods are bad or unreliable or not justified, but most of them work on a scale of long-term time intervals. In fact, there is only one known case of successful prediction from history in China. I do not remember. I think in the year 1975. There, interestingly enough, not only physical precursors were used, but also biological ones, i.e., abnormal behavior of animals when, in winter, snakes come out to the surface and so on. And this is the only time when measures were taken, and a day or two before the earthquake, the population was evacuated. The earthquake occurred, and a lot of people were saved. But unfortunately, a few years later, there was about the same earthquake in the same region, and more than 100,000 people died there. It hadn't been predicted.